Good morning or good evening, everybody, mga kababayan. Today's video is about mastering multiplication and division of radicals. And we have another word right here from the word master. So this is another mastery video on multiplication, division of radicals. So in gaining mastery on any skill, practice is necessary. So before we start, I would like to say thank you for helping me make more videos if you subscribe to my channel. Alright, so in multiplication and division of radicals needs prerequisite knowledge in simplifying radicals. And in simplifying radicals, the rules that govern are: first, in fractional radicals, there should be no radicals in the denominator. Second, the radical cannot contain fractions. And third, the radicand cannot contain perfect square factor. And we have here some examples. 2 square root of 16 multiplied by 3 square root of 18. And here a fractional radical, 12 divided by 7. And on the bottom we have here a complex radical expression. Square root of 12 times square root of 24 divided by 3 minus square root of 5. Okay, so let's start and go ahead and start solving problem. We have here number one problem. 2 times the square root of 3 squared multiplied by 15 times the square root of 45. So once again, in simplifying radicals, there should be no perfect squares in the radicand, and the radicand must be fully factored. Okay, so in here, 2 times the square root of 3 squared. 3 squared is the same as 3 times 3, or that's 9. So that's the square root of 9 times 15 times the square root of 45. What are the factors of 45? So we split this one into 9 times 5 is 45. So this is a perfect square, as well as this one right here. So get rid of that perfect square out of the radicand. So we simplify further. That's 2 times square root of 9 is 3 multiplied by 15 times the same way in here. This can be split as square root of 9 times square root of 5. So, and this is square root of 9 is 3. So that is 3, then square root of 5. Now in multiplication of radicals, all we have to do is just multiply all the terms and their coefficients. That's what it is in multiplication. So we start multiplying the terms now. So that is this one right here. Okay, and this one. So that is 3 times 3, 9, times 2, 18, times 15 is square root of 5. And this one is 18 times 15, that is 270 square root of 5. So that's the answer. So we have number 2 problem. The square root of 4 times the quantity 2 cubed plus 3 squared raised to the second power times 2 times the square root of 25. So in here, whenever we encounter this kind of radical, the radicand has parentheses. All we have to do is simplify those numerical values inside the parentheses first, and do the second one. The exponent will be the next. It's like simplifying integers by doing PEMDAS. Okay, so let's go ahead and solve it. So in here we just copy everything and simplify what's inside this parentheses. 2 cubed is 8, 2 times 2, 4 times 2 is 8, plus 3 squared is 3 times 3 is 9, and it's squared as square root multiplied by 2 times square root of 25. 25 is perfect square, so that is 5. Okay, so move further. We have here now square root of 4 multiplied by what's in the parentheses. 9 plus 8 is 17. and that's square, and that's square root, multiplied by 2 times 5 is 10. Okay. So in here, we can split this one right here into, this can be written also as square root of 4 times the square root of 17 squared multiplied by 10. And to simplify further, it's square root of 4 is 2. So we just bring this down right here now. Bring this, all these, so that's square root of 4 is 2 multiplied by 10. And square root of 17 squared. Since the square root sign is represented by an exponent 1/2, see this one right here, 17 squared. That is 17 squared raised to 1/2 power. So in this case, if you simplify that, that will come up to just 17, since you're multiplying 2 by 1/2, 2 over 1 or 1/2 by 1/2. So that cancels 2, that becomes 1, so it'll be 17. So this will come out to square root of 17, cancel the radicand, and cancel the 2 right there. So it'll turn up to 17. So what we have to do is just multiply all these numbers. 17 times 2 is 34, times 10 is 340. So that's 340. So that's the answer. Now, when it comes to division, it's a different way. And in dividing radicals, the rule says that there should be no fractional form inside the radical. So this is in the form of fraction. So what we have to do is get rid of the fractional form in the radical. Okay, since we have here number 1, square root of 28 over 52. So first thing first to think when you're simplifying fractional radicals, what you have to do is investigate the numbers and as much as possible reduce those numbers to their lowest term. So to avoid simplifying big numbers, the square of 28 and 52 divided by 52 can be divided by 2 on both the top and bottom of the radical. So that will reduce to square 28 divided by 2 is 14, and 52 divided by 2, that's 26. Since 25 is 50, so 26. Okay. Alright, so that becomes 14 over 26. And yet we can still reduce that one right there, by the way. So let's divide by 2 again. So divide by 2, top and bottom. So that will end up to 7 over 13. And that radical right there can be expressed the same way as square root of 7 divided by square root of 13. So now you have the bottom, you got the radical on the bottom. That means the denominator of that. The rule says there should be no radical in the denominator. So to get rid of that radical in the bottom, all we have to do is multiply by itself. So let's do that. So that will become square root of 7 divided by square root of 13. Multiply the whole term by square root of 13. The numerator and the denominator. And this becomes square root of 7 and square root of 13 divided by 13. Since the square root multiplying it by itself will negate the radical sign. So in here, once again, that's 13. That's the same way as square root of 13 squared. So now in here, if you notice, these are prime numbers already. What does it mean by prime numbers? Prime numbers are those numbers where if you factor out, the only factors of these numbers are 1 and by itself, like 7 and 1, that's the factors of 7. Same way with 13, it's prime number. There's no other number that can be factored, can be other factors except by itself and 1. And that's how to simplify. So in here, so this should be the final answer. So square root of 7 times square root of 13 divided by 13. So that's the final answer. So we have here number 2 problem, square root of 32 divided by square root of 40. This problem can be written the same way as square root of 32 divided by 40. And now, if you take a look, the radical contains bigger numbers. What we have to do is just simplify this into their lowest terms so we can avoid dealing with large numbers, right? And think of a number that we can both divide by both of these top and bottom of the fraction to reduce these numbers into their lowest terms. So divided by what number? So we can divide this by 4. Okay, so the top and bottom divided by 4. So it won't alter the quantity of the numbers in the radical, since 4 divided by 4 is 1. Okay, so 32 divided by 4. So 8. 40 divided by 4, that's 10. So that is square root of 8 over 10. And yet, once again, we can still divide this by 2 again. Okay, so that will become 8 divided by 2 is 4. 10 divided by 2 is 5. So that's square root of 4/5. Now, reduce it further. Well, that will be written again as square root of 4 divided by square root of 5. Simplify this one right here to dissolve the square root on the bottom. Multiply this, the whole term, the top and bottom with the square root of 5. Same way on the top. Okay, so that will be square root of 4, square root of 5, divided by 5. To reduce it further, okay, this is square root of 4 is 2, square root of 5, divided by 5. So that's the answer. We are now on multiplication and division. So this combines multiplication and division now. So we have a problem. So we have here square root of 16 times square root of 35 divided by 3 square root of 20. Square root of 16 is a perfect factor. So that square root of 16 is 4 multiplied by square root of 35 divided by 3 times square root of 20. Okay, so we have to get rid of this radical in the bottom. Okay, what we have to do is multiply the whole term, top and bottom, with square root of 20 to get rid of that radical right there on the bottom. So that will end up to, okay, that will be 4. And we find to break this one, they split this radical right there. So we have to deal with those. So 35, what are the factors of 35? So that is 5, 7 times 5 is 35. That is square root of 7 times 5. And then square root of 20, factors is 5 times 4. Or 10 times 2. Let's do 5 times 4. 4 times 5. Same way. Divided by 3 times, getting rid of that radical sign, that's 3 times 20. So this now becomes the square of 20 is 4 times 5. Okay, and the denominator becomes 3 times just 20 itself, cancelling the radical sign. Okay, so simplify it further. So write down over here again. So that is 4 square root of 7 square root of 5, splitting that thing right here, multiplied by square root of 4 square root of 5 divided by 3 times 20, that's 60. So in here, okay, so we see this square root of 4, that's 2, perfect square. So put that one right there, that means 4 times 2 now, times square root of 7, times you have 2 square root of 5s. Okay, divided by 60. See, if take a look at this square root of 5 multiplying by itself, that cancels the radical again. So that will end up to, so 4 times 2 is 8, times 5, square root of 7, divided by 60. So that's square root of 7 right there. So 4 times 2 is 8, and then square root of 5 times square root of 5, that cancels the radical, so it becomes 5. So 8 times 5, square root of 7, divided by 60. So that will become 8 times 5 is 40, square root of 7, divided by 60. Now all we have to do is reduce this to its simplest term. Cancel the 0 right there, and that becomes 4 over 6 square root of 7. And yet we can still simplify this one right here, dividing both by 2. That'll become 2, and 6 become 3. So that is 2/3 square root of 7. That's the final answer. And here is our last problem. 2 times square root of 10 divided by 3 plus square root of 2. If you notice, the bottom of this fraction is, it has an addition of radical, a whole number and a radical. And how are we going to simplify that? To get rid of that radical on the bottom, all we have to do is multiply the whole top and bottom with the conjugate of this bottom number, 3 plus square root of 2. And what does it mean by conjugate? Conjugate is the same as the terms, but with different sign. The opposite sign in here is positive, so that should be a negative. So let's do that. Multiply the top and bottom with the conjugate of the denominator. Oh, let's go ahead. So 2 times square root of 10 divided by 3 plus square root of 2. So multiplied by the conjugate of this. Alright, so that is 3 minus square root of 2. You do on the bottom, you do on the top the same way. So multiply by 3 minus square root of 2. So simplifying this further, now all we have to do now is distributive property, multiply this to that first term, second term. So that is 3 times 2 is 6 square root of 10 minus 2 square root of 10 times square root of 2. So 2 times square root of 10 square root of 2 divided by, so this, the whole term multiplying that, it's like just like a binomial. Alright, but these are numbers. So 3 times 3 is 9. Then 3 times negative square root of 2, so that's minus 3 times square root of 2. Okay, now we go to the second term. Say square root of 2 times 3, that's plus. So 3 square root of 2. And then the last term, minus plus, so that is minus square root of 2 times square root of 2 multiplied by itself, square root of 2. So that's what is square root of 2 times square root of 2. That's the same way as 2 1/2 raised to the power of 2. So that's the same way as raising this 2 to the 1/2 multiplied by itself. So that cancels the 2, so it will become just 2. Okay. Alright. So go ahead and simplify it further. This one right here. So So you rewrite over here. So 6 square root of 10 minus 2 square root of 2, and 10 can be broken down and split it into its squares. I mean its factors. So that is square root of 2 square root of 5 divided by, so 9 and these two terms right here cancelled, so that is 9 minus square root of 2 times square root of 2, that becomes just 2, so that is minus 2. Okay, so we have here, so once again just write it down again. Square root of 10 is square root of 2 times square root of 5 minus right here 2 times square root of 2 times, this can be split, square root of 2 again, square root of 5 divided by 9 minus 2 is 7. Okay, so what we have here now, if you notice this 2 and square root of 2, that becomes just 2. Okay, so let's go ahead, simplify. 6 times square root of 2 square root of 5 minus 2 times 2 now, since this square root of 2 times square root of 2, it negates the radical, so it becomes 2 square root of 5 divided by 7. Okay, simplify further step by step. So 6 square root of 2 square root of 5 minus 2 times 2 is 4 square root of 5 by 7. Okay, now we have here, right here, we can factor out this out, square root of 5, and then factor this out, the coefficient of 4 and 6, factor out 2 out of that. So that's 2 and square root of 5 multiplied by, so 3, since 3 times 2 is 6 and the square root of 2, minus what's left on this, on the right side, factoring 2 out of 4, that's 2 divided by 7. So this becomes 2 divided by 7 square root of 5 times the quantity 3 square root of 2 minus 2 as the final answer. Now, before we conclude our lesson today, mastering multiplication, division, and radicals, those 3 items, problems to be solved for you guys, I left this out for you guys to solve as practice, so you can get mastery in multiplication, division of radicals. And I will give you the answer. Now, if you noticed, I put the answers right here on the right hand side of each problem for you guys to solve to gain mastery in the multiplication, division of radicals. So these are the answers, so you can compare your answers with. Okay, so after this lesson and after practicing solving these radicals right here, you should consider yourself a master, but then you have to follow the rules in simplifying radicals. Those rules are, once again, firstly is there's no fraction in the radical, and then if ever there's a fraction on the bottom of it, the denominator should never have a radical. And third, all the radicand should be reduced to their lowest terms. That means there should be no perfect squares in the radicand. Alright, that's all for today. Once again, I would like to say thank you if you can subscribe to my channel so I can make more videos in the future. Have a great day, guys. Have a great day, everyone. Thank you for watching. Maraming salamat po, mga kababayan.